Electrolysis. Welcome to all NSSC Advanced Subsidiary Chemistry learners and everybody else interested in chemistry. We appreciate your company. From the Namibian College of Open Learning, NAMCOL, we have been offering you a series of 5 radio lessons on different interesting topics in your Advanced Subsidiary or AS Grade 12 Chemistry syllabus. In Lesson 1, we discussed the framework structures of crystalline solids. Then in Lesson 2, we submitted 4 Group 2 elements to experiments to see their reactions to oxygen and water. Lesson 3 saw us sweating over the relative masses of atoms and molecules. In Lesson 4, we discussed the chemistry of nitrogen and its application in industrial and organic fertilizers. And in this final lesson, Lesson 5, we are discussing electrolysis. If you are a NAMCOL student, you will find this topic in your textbook AS Level Chemistry Learners book in Unit 2.2.2, page 100 to 105. So in this lesson, we will explain what electrolysis is. We'll identify the electrode products of watery solutions and finally discuss the processes involved in the transfer of charge during electrolysis. Please join us in the discussion. Ushona, your turn to speak. Ushona!
Sorry, Miss Bolton. Have we started already? I was concentrating so hard here. I didn't hear.
Yes, I see you concentrating very hard. What are you doing?
Trying to connect this wire to the battery. You asked me to have this ready before you came, but the taxi brought me late.
Let me see if you've got everything we will need. Aha! Here's the battery, the connecting wires, and you've got the 2 graphite rods dipped in water.
Yes, I got it all, ma'am. I'm curious to know what we're going to do with it.
We're going to learn about electrolysis.
Electrolysis? You mean like my sister goes for at the beauty salon for hair removal?
That's right. One of the applications of electrolysis as a process is hair removal in beautician science. Today's medical electrolysis can be used to remove individual hairs from the face or the body. The process destroys the growth center of the hair with chemical or heat energy. In chemistry, though, we're just looking at how it works.
What a relief we're not studying beauty science. Body operations are not for me.
All right then, let's focus on the chemistry. Electrolysis is the passing of a direct electric current through an electrolyte to produce 2 things: chemical reactions at the electrodes and decomposition of the materials. The main components required to achieve electrolysis are an electrolyte, electrodes, and an external power source. That's what we have here. A partition acting as an ion exchange membrane or a salt bridge can help to prevent the products from diffusing to the opposite electrode.
I think I'm a bit lost, ma'am.
Okay, let's take a step back. Electrolysis is a tool to study chemical reactions and obtain pure elements. The electrolyte is a chemical substance which contains free ions and carries electric current. If the ions are not transportable, as in most solid salts, then electrolysis cannot occur. So, a liquid electrolyte is produced through the reaction of an ionic compound with a solvent, such as water, to produce mobile ions.
Man, who thinks up all these things?
Well, if you're a scientist, you want to experiment. That's how the idea of a mad scientist came about. People have tried out all kinds of experiments for all kinds of reasons, and that's how science evolves. Experimentation with electrolysis began at least 300 years ago when they created an electrostatic generator to reduce tin and zinc from their salts.
Oh, yes.
They attach two wires to either side of a voltaic pile and place the other ends in a tube filled with water. They noticed when the wires were brought together that each wire produced bubbles. One type was hydrogen and the other one was oxygen.
Oh, wow. They separated the two gases from each other?
Yes, but wait, it gets madder than that. A Frenchman later experimented with frog legs. He claimed that placing animal muscle between two unrelated metal shields resulted in electricity. The experimentation developed like a race among scientists. The next discovery was proof that when two elements combine together to form a compound, electrical energy is released. Still later, they could create decomposition tables from their preliminary experiments on electrolysis. The decomposition tables showed the energies needed to break apart certain compounds.
Okay, that's all very interesting. Let me see if I've got it so far. As I understand, it is hard to get some compounds to react to others, so chemistry and manufacturing use electrolysis for it. Electrolysis is then a technique that uses direct electric current force a chemical reaction to take place.
Exactly, Ushona. You say it better than me. Now, electrolysis is commercially important as a stage in the separation of elements from naturally occurring sources such as rocks and underground ores using an electrolytic cell. The voltage that is needed for electrolysis to occur is called the decomposition potential. The word lysis means to separate or break. So the term electrolysis means breaking down through electricity.
And what does it actually break down?
The electrical current breaks down into ionic compounds into their individual elements.
Can you show me, please?
Yes, I have now connected the wires and the battery that you struggled with. Now watch. The two electrodes are immersed in the water, not touching but separated by a distance, such that the current flows between them through the electrolyte. The two electrodes are connected to the power source, which completes the electrical circuit. See? The direct current supplied by the battery as the power source drives the reaction. What do you observe?
It looks like the ions in the electrolyte are attracted towards both of the two respective oppositely charged electrodes.
That's right. The ionic compound has decomposed, and the parts it consists of are now separating. Electrodes of metal, graphite, and semiconductor material are widely used in electrolysis. The choice of what type of electrode is suitable depends on the chemical reactivity between the electrode and electrolyte and manufacturing costs. Historically, when non-reactive anodes were desired for electrolysis, graphite or platinum were chosen because they were found to be among the least reactive materials for anodes. Platinum erodes very slowly compared to other materials, and graphite crumbles and can produce carbon dioxide in aqueous solutions but otherwise does not participate in a reaction.
Just seeing again whether I understand correctly, Miss Poulton. So, electrolysis is the conduction of electricity by an ionic compound, which is an electrolyte, being decomposed when molten or dissolved in water.
Correct.
And they can even separate hydrogen and oxygen from water when it is decomposed.
I told you. That's been done hundreds of years ago already. But pure water cannot conduct electricity though, because it has no ions that can move and carry charge. They have to add sulfuric acid for it to conduct electricity.
And from the table salt, they can collect its compound parts, sodium and chlorine.
Yep, depending on the state it's in.
Shoo, that's so cool. The battery is obviously the power source that supplies electrons to the circuit.
Yes, and the two rods are called electrodes. They are made from graphite. The electrode connected to the negative side is the cathode, and the electrode connected to the positive side is the anode.
And the name electrolyte?
The name electrolyte is given to the substance that is decomposed. For example, the molten table salt or sodium chloride. It can be in molten form or dissolved in water.
This is very informative. So, how does the decomposition take place?
Once I close the circuit, the electric current passes through the electrolyte. And look, the positive ions, which are hydrogen ions in this case, are attracted to the cathode, where they gain electrons to form hydrogen gas. In this electrolyte, you also have the negatively charged ions, the hydroxide ions and sulfide ions. The hydroxide ions are more easily discharged than sulfide ions, and so they are attracted to the anode, where they form oxygen and other products. You actually have to write these reactions down to see and understand them better.
So, what if the electrolyte was molten sodium chloride?
Then the electrolyte would contain sodium and chloride ions. So the sodium ions, which are positively charged, would move to the cathode, where they each gain an electron to form sodium metal. And the chloride ions, which are negatively charged, would move to the anode, where they lose electrons to form chlorine gas.
How do I know what the products will form?
To identify the electrode product, selective discharge takes place. The product formed depends on three factors: the position of the ion in the reactivity series, its concentration, and the type of electrode used. Oh dear, our time is up. Let me just say, through selective discharge, scientists have observed that electrode products of aqueous solutions could include two types: hydrogen ions and metal cations, including silver, copper, iron, zinc, and sodium. And non-metal anions include hydroxide and chloride, forming in diluted and concentrated solutions.
So, apart from hair removal in salons, what else are the uses of electrolysis in the manufacturing or chemistry?
What a great question, Ushana. Listen well. Applications: electrometallurgy includes reactions involving aluminium, lithium, sodium, potassium, magnesium, calcium, and in some cases copper. Other uses include electroplating, purification of copper, production of fuels such as hydrogen for spacecraft, nuclear submarines and vehicles, as well as rust removal and cleaning of old coins and other metallic objects.
So many uses.
Yes, chemistry has become quite an advanced science. Now, let's summarize our lesson of today. You have heard and learned that electrolysis is the breaking down or decomposition of an ionic compound that occurs through an electric current. The ionic compound, which is an electrolyte, is either in a molten state or dissolved in water. Electrodes are rods made from graphite or a metal such as copper, which conduct electricity to and from the electrolyte. During electrolysis, electrons move from the negative side to the positive side. The anode is the positive electrode and the cathode is the negative electrode. Positive ions called cations move to the cathode, where they gain electrons to become neutral. Metal and hydrogen ions are positively charged, so they always move to the cathode. Reduction also takes place at the cathode. Negative ions, called anions, move to the anode, where they lose electrons to the anode. Non-metal ions move to the anode because they are negatively charged, and oxidation takes place at the anode. Selective discharge takes place to identify the electrode product. The product formed depends on the position of the cation in the reactivity series, where the lower the reactivity, the more easily discharged the cation is. The product formed also depends on the position of anion in the reactivity series, where anions with lower reactivity such as hydroxide ions are more easily discharged. Finally, the product formed depends on the concentration of anions in the solution. Higher concentrations of ions are more easily discharged.
That's a lot to take in, but I'll go over it in my learner book again. Thank you for the lesson, Miss Polton. Goodbye, fellow learners. Best with your exams.
Listeners and learners, please also remember that NAMCOL has many more radio lessons that can help you brush up on school topics in your grade. Check out our website on www.youtube.com/NAMCOL81. Now we'd like to thank Fiona Kubaula, who wrote the lessons for this series, and others in the NAMCOL team who improved on them. Ms. Audrey Polton is the program developer for the advanced subsidiary NSSC AS Chemistry subject. We also acknowledge our off-site script editor Lynette Smith. Ms. Audrey Polton is also NAMCOL's coordinator for e-learning materials development, and Manfred Isaacs is NAMCOL's educational broadcast coordinator, who brings everything technical together. Thanks for tuning in, and I join Ushona in wishing you all the very best of success in the exams. Goodbye.
This lesson is produced by NAMCOL with funding from the Ministry of Education, Arts and Culture.